All right, hello everybody. My name is Jim Pingle and welcome to our August 2016 Hangout on providing local DNS. We're using the DNS Resolver and DNS Forwarder, of course. All right, about this Hangout. First we're going to do project news as usual. Then I'll have an overview of what DNS is and how it works. Just a very light, high-level overview. When you would want to use the firewall for DNS and when you would not want to. Some differences and similarities and capabilities of the DNS Resolver and DNS Forwarder. Then I'll talk about host overrides, domain overrides, DNS and VPNs, DNS and Multi-WAN, and DHCP and DNS, and how the firewall assigns DNS servers to clients, which is related to DHCP there. Talk a little bit about intercepting DNS at the firewall, and have some miscellaneous additional resolver and forwarder bits that didn't quite fit into any other category. Okay, first up is our project news. We're going to have 2.4 alpha snapshots available soon, maybe over the weekend or by Monday, sometime around then. They're definitely not production ready. They're only for alpha level testing, so expect some breakage, expect things not to work, and there might be some missing features yet. It does have ZFS available in the installer if you have a system with sufficient RAM. We don't have any good guidelines on that yet, but as the release gets closer, we'll have some better guidance there. We have posted a little bit more about our micro firewall product that we're working on. You can see the picture of it over there. It's a little ARM board with two Ethernet adapters that are on there that are gigabit, and it's a really nice little unit. Jim Thompson posted a video on Twitter of it running a 2.4 alpha snapshot. It's really cool. It's making a lot of good progress. We have our official pfSense training in St. Petersburg, Russia that we're going to be having during September. So if you're in that neck of the woods, keep an eye out and we'll have some announcements about that. Just a reminder, they're still fairly new. We do have our official pfSense Facebook page at facebook.com/pfSense, and we have an official pfSense Facebook group at facebook.com/groups/pfSense.official. If there are any others out there that you might have been in, just might that we had to start our own because there were some issues with the other ones. So we like to have these here and give them a shot. Moving right along. First up, what is DNS? It stands for Domain Name System. Basically, it translates host names and IP addresses, and the most common analogy you'll see is comparing it to a phone book. Since your client software has to talk to an IP address, it doesn't know the name, so the DNS makes it easier for humans like us to remember these addresses without having to memorize the IP addresses. So you just type in www.example.com and it goes through the whole DNS process and it spits out an IP address like 203.0.113.65, and then the client can communicate to the IP address. There are several different types of records in DNS for different tasks. We've got A records for IPv4 addresses, quad A records for IPv6, PDRs for reverse DNS, MX for mail exchange for like looking up an SMTP server for a domain, CNAME records, which are sort of like aliases, service records, text records, and so on. Text records are commonly found for like SPF for mail or lots of other uses. There's tons of things you can do with DNS, and I'm not even going to scratch the tippy top of the surface here. The DNS structure is made to be very widely distributed. As a client or a stub of sorts, you'll talk to a recursive forwarder or resolver ahead of you. That if what you're talking to is a forwarder, it will in turn talk to a resolver. And then a recursive resolver. And then that recursive resolver will go out and it'll talk to the root servers, and from there it will find authoritative servers and so on. And then the message will be passed back, which I'll expand on here in a second. So when a client makes a query, it uses UDP port 53 by default, and it will ask for a specific record and a specific type for a given host name. And depending on the size of the result, it can switch to TCP. So when you're dealing with firewall rules and NAT and things for DNS, you always have to use both TCP and UDP on port 53. So if the forwarder or resolver knows the host locally, or if it has the answer in the cache, it will reply back immediately back to the client. If it doesn't know the answer, it will ask upstream. If you're talking to a forwarder, it will go on to another recursive resolver, or on up the chain. It could be forwarder to forwarder to forwarder. Eventually it will get to a recursive resolver, and then a recursive resolver will talk directly to the root servers. And it'll ask the root servers, hey, who's the source of authority for this domain? And then it'll get an answer back for that, and then it will contact those authoritative servers listed in the response. So all in all, it's trying to find who has the answer to that question, and then whoever has the authoritative answer, it will eventually pass that back on through the recursive resolvers and forwarders back down to the client. So, and sort of was what I was mentioning, just to reiterate, a forwarder has to talk to an upstream recursive forwarder or resolver. So sort of like a client. A forwarder is in itself a client of sorts. It can't do the resolution part itself. It's basically a middleman. It can be a caching middleman like our DNS forwarder, but it doesn't do the resolution on its own. But contrast that to a resolver, and a resolver can operate independently. It can talk to the root DNS servers and other servers directly. All right, so why would you want to use the firewall for your DNS? Well, the firewall is placed conveniently to handle DNS for local clients. The host and domain overrides allow customization and control over the DNS responses given to clients. So it lets your firewall basically hand out whatever answers you want to clients. It easily integrates with our DHCP server for resolution of client host names. So out of the box, you can have integration with DHCP and DNS all on the firewall. It is it can locally cache DNS responses, so you can speed up resolution, and it saves time and repeated or frequent queries. Like if everybody is looking up google.com, you don't need to send that query for google.com out to all your DNS servers every few seconds when somebody does it. It'll answer it out of the cache locally, at least as long as the record is valid. It can also lead to more efficient selection of upstream DNS servers. So if you have an upstream DNS server that's slow or broken in some way, it's not going to keep you down for too long. Whereas if you have two your DNS servers on the clients directly, and the first one goes down, it's going to have to wait about 45 seconds for that to time out before it falls over to the second one each time. Whereas both the forwarder and the resolver both have a means to handle that a lot nicer. And also, it is less effort than running a dedicated full-featured DNS server, but you have less features than a full DNS server. So it's easier, but it lacks features. I see somebody was asking about the audio. Is it better now, the audio? I'm having some issues with my headset today, and I was trying to dial that in. Okay. All right. There we go. Okay, thank you. All right, so when would you not want to use the resolver or forwarder? Well, you wouldn't want to use it if you have a complicated DNS setup or complicated requirements. If you have multiple sites, like say they're connected by a VPN, MPLS, or whatever, if they all have to share the exact same domain name at all the sites, and all of those host names have to be visible to all the clients, you can't pull that off with the forwarder or resolver because they're going to want to bounce that question off each other constantly, and it's just going to keep looping and looping because, if you ask for something that doesn't exist, one's going to ask the other, says, I don't know, ask you, and then they'll go back and forth. In a case like that, you really need to have a separate DNS structure where these things register to that's outside of the firewall, and that replicates from DNS server to DNS server, where it actually replicates the entire zone across. So all the sites have access to all the same zone data, or they're all accessing the same DNS server, which is okay, but not great, because you end up with some redundancy issues there. Or lack of redundancy issues rather. There are ways to overcome that, but they are not using the firewall. You need a lot better DNS structure for that. Also, if you want to provide different responses to different sets of local clients, the DNS forwarder can sort of fudge that if there's the same host name in in two different local segments and two different IP addresses that exist in two different local segments, you can kind of do that with some advanced options, but it's kind of ugly. So I mean, if you need like group A to get this answer and group B to get that answer, it's not going to work on doing that on the firewall effectively. You're going to have to use some external DNS server that supports the concept of views or some way of filtering queries by the other. There are some tricks where you can kind of make that work if you run both the resolver and the forwarder, and you have some host names in each of them, but it's kind of kludgy and it's not really a great thing to do. You don't really want to go down that rabbit hole. It can only do two separate things for first off, so it's not really that flexible. And second of all, if you are trying to do that, there's still a couple of edge case bugs that we hit every now and then with trying to run both things at once, and it's not ideal. Okay. And also the last one I could think of off the top of my head here earlier, if you have clients that must register host names in different domains on the same local segment. So say you have two different servers in your DMZ that need to register a host name in two different domains, that's not going to work, because when it registers, it's going to use just this whatever domain is on the firewall. It's not gonna be able to register a completely different domain automatically with the DHCP stuff on pfSense. Whereas if you have like self-registration set up in a proper DNS structure, that can work depending on your client and your DNS server. Another time you would not want to use it, the resolver or the forwarder, is when your local network has an Active Directory domain. When you have Active Directory, you really want to be using that AD structure for DHCP and DNS on your clients. That make sure they get registered properly, their host names resolve, and that you get service location and all the features and things from AD. If you do want to have the forwarder or resolver involved, you have your clients talk to your AD structure DNS servers, and then you can list the firewall as a forwarder for that. And so, everybody queries the AD server talks to the firewall, and the firewall in turn talks to either another forwarder or it does the recursive resolving itself. That kind of gets you the best of both worlds, but you really don't want those clients to be accessing the firewall DNS server directly unless, you're willing to work around all the quirks you'd have to work around otherwise. It's just a lot cleaner to let AD do all that stuff for you. And lastly, you don't want to use the resolver or forwarder if you expect to be providing authoritative answers to public clients. Like, you're not going to be able to set up host overrides and then have it act as an authoritative server for public access. A, because it's not secure. B, because these are not going to be set up in a way to provide that authoritative answer in a way that's going to function for public DNS. And if it is open to the public, it's going to end up allowing recursion in most cases, which is going to let you get exploited as a denial of service vector for like a reflected DDoS type thing. So that's not great. So if you need authoritative answers for public clients, you need to have a separate dedicated DNS server or something running something like bind off the firewall, ideally. Okay, I'll talk a little bit about the DNS Resolver on pfSense. This has been our default for DNS since 2.2. If you were running the DNS forwarder on an older version and you upgraded, it would continue to let you run the forwarder. But if you start fresh on 2.2 or later, like our 2.3 releases, it will start you out with the resolver enabled. The DNS Resolver in the backend uses the unbound daemon, which is a secure caching validating resolver included in FreeBSD. We moved to that because FreeBSD was moving to that, and we saw what it can do, and we wanted to follow in line with them. And the great thing about a resolver is that it operates independently. You don't need upstream forwarders. You don't need to go into system and general setup and put your DNS servers in there, because it can talk to the routes directly. Because it's a resolver, it can handle the more complicated task of seeking out the authoritative answers on its own. So because of that, because it's automatically going out and doing all that without your manual intervention, it's a really good out of the box experience, because you don't have to worry about somebody going in and manually setting their DNS or receiving it from DHCP. It just sort of works, and they don't have to know about it or care about it. It's just there, and it does its job. Now, we have seen a couple of rare cases where an ISP will filter or rate limit access to other DNS servers. So they've noticed that they were using the resolver and it worked for a while and it stopped, or the resolver didn't work in normal mode. So you had to switch over to forwarding mode and basically go back to that behavior. That's atypical behavior, but it is not unheard of. So there have been cases where we've had to switch Unbound into forwarding mode, which it can do. It can act sort of like the DNS Forwarder does. It will respect those servers if you want. But in those cases, you can work around it, but it's still, for the vast majority of people, it's the best thing to do out of the box. And because it does contact the root servers directly, multi-WAN can be a little tricky, but I'm going to be covering multi-WAN in a little bit here separately. As I mentioned, Unbound can operate in forwarding mode, so it can work. It can take your DNS servers, and it will take that list of DNS servers, and it will randomly pick one of them, and it tries to query all of them. It keeps track of which ones are coming fast and which ones are slow, and it will send a given query to just a random one, but if one does go down, it will take it out of the rotation. This command I've listed down here, this unbound -control -c, and then the path to the config, and then lookup space dot. If you run that, it will show you what I've got open here in this other window. It shows you each of your DNS servers, what your round trip time is to them, how fast what kind of ping responses you're getting from them, and whatnot. So it tracks a lot of information in the background about these DNS servers, and it will try to keep using the ones that are responding fast and efficiently. So those are handy to see. Now, most of the time you don't have to care about that, but if you notice something weird going on, you can try that command. We don't have that a way to look that up in the GUI, because for the most part it's not necessary. It's interesting to see, but it's not required. Another great thing about Unbound is it natively handles DNSSEC, or the Domain Name System Security Extensions. And DNSSEC is kind of confusing for some people because it provides authentication and integrity confirmation. So basically it proves that the answer you're getting is the right answer, and that the answer came from the correct source. So it stops things like forged responses, cache poisoning type things. Spoofed DNS results. Like if you're trying to get the answer and it's been spoofed, you get the wrong answer. It does provide that integrity and authentication and validation, make sure you're getting the right answer. What it does not do is encrypt anything. It's signed, not encrypted. And DNSSEC works great in resolver mode because it's talking right to the root servers and other authoritative servers. It can get the information directly. If you're in forwarding mode, your forwarders have to support DNSSEC, whether you're forwarding to another forwarder or you're forwarding to another resolver. As long as the upstream server supports DNSSEC, you should be all right. Like Google Public DNS, I think supports it, but some other ISP-enabled or ISP DNS servers probably don't. And another good thing about the resolver is there are many options for tuning and optimization. Scales better for a large number of clients. So over here, like in your advanced settings for the forwarder, log back in. Back to the resolver. Under advanced settings, there are a lot of things you can tweak to, for security. You can hide some information about it. You can improve performance. You can tune the message cache sizes and buffers and lots of various fields that you can tweak in here to get better performance out of it for larger deployments. So most people are not going to have to touch these, but if you find your DNS performance isn't quite what you want, you can always come in here and tweak things a little bit, increase, decrease the cache, whatever you find you need to do. In terms of access control, by default, Unbound will allow access for all of your local networks, but if you find that there's a network that's not listed that you need to have access to it, say it's across a VPN, or some of the remote network that you want to allow through. You can always add an ACL. You can also deny specific ranges or your subnets or addresses from getting through with an ACL as well. And so you can deny, you can refuse, sorry, and you can allow, or you can allow snoop. The refuse action here actually sends back a refuse. So sort of this deny is sort of like a firewall block. Refuse is like a firewall reject. So a deny will just drop it. Refuse will send back a message saying it dropped it, which is kinder for local clients, but if it's something you think is malicious, just outright deny it. Allow just fine, and allow snoop is used for cache snooping. It's a little bit more advanced, not something I'm going to get into, but it's there. If you know what it is, you need to do it. So by default, again, most people don't have to touch this, but it's there if you do. You can actually disable the default access lists and put in your own, which is handy. And there's also custom options, of course, where you can define your individual advanced options that aren't in the GUI, which is handy. Here's the DNS query forwarding. If you want to turn on forwarding mode, just check that box. I had that on here to show that unbound command. And if you need to disable DNSSEC for some reason, you can just uncheck the box. DNSSEC is on by default. You can turn that off if you need to. All right. So that's about it for most things that you'd ever really need to encounter on the resolver. Let's move on to the forwarder. DNS Forwarder is a lot simpler than the resolver. It is only a forwarder, not a resolver, now that you know the difference. It uses DNS mask, which is a lightweight caching DNS forwarder. So it still caches, and it can still do some nice custom things. It does have a couple of features that Unbound doesn't. However, it does require you to have defined your upstream DNS servers. So you do have to go under System in General and fill in your System in General setup and fill in your DNS servers there, or obtain some automatically from a DHCP or PPPoE WAN. By default, the DNS forwarder will query all of the DNS servers at the same time and return the fastest result. So that's really nice for multi-WAN, especially because it'll send out, if you have your, what we'll talk about in multi-WAN in a little bit, if you have a DNS server set for each WAN, it's going to be sending queries out every WAN. It'll take whichever one comes back fastest, which is, again, really, really nice for performance and reliability. So it's very robust. The downside of that is you can run into a situation where if you have a specific order of DNS servers that you prefer, it can mess with that. So say you want your clients to get answers from a local DNS server first, but you also want to list, like say, Google public DNS servers to make sure that they have something to fall back to if the local one doesn't answer. You know, that parallel query is gonna mess with that. You can turn that off here under DNS query forwarding under services and DNS forwarder. If you check this box, it will query the server sequentially. You will have to deal with some timeouts, but it will ensure that your queries come from the servers you want in the order that you set them. So most people don't want to set that, but in specific circumstances, like I mentioned with ordering, you might want to check that. There's also a couple of other options here under the forwarder that you might want. I'm going to talk about the DHCP options here in a minute, but you can set the listening port. So if you want to run the forwarder and the resolver at the same time, they both had a listen port option. You just need to make sure they're set to different ports. You can also set the listening interface, which on the resolver, you could set the network interface, which is the interface it listens on for queries, for local queries. And also you can set the outgoing network interface, which is the interface that it will send a query out from the resolver using, which that'll come into play more with VPNs, and I'll get to that in a little bit. Now, over here for the forwarder, you know, it's going to bind, or it's going to, by default, it's always going to bind to all interfaces. And even if you select an interface here, it's going to bind to everything but only answer queries here. If you check the strict binding box, it will only bind to your selected interfaces, which can help in some cases. It's a little bit more secure, but unless you have interfaces that you definitely are not trustworthy, you may not really need to bother with that. Especially since you can take care of that in firewall rules as well. But there are cases that might require you to use strict binding, especially if you're like strict binding just like localhost or something on an alternate port. And again, custom options similar to the resolver, where you can put in parameters to pass right over to DNS mask. Another option I didn't say, this require domain up here. If you have this checked, it is going to not forward on a query if you just pass it a host name, because by default it's going to try to tack on the domain of the firewall to try and get that resolved, so it can sort of bleed that request out. But if you have that checked, if it's just a plain name and it doesn't have just a plain name answer, it will just not return a response, which is a little bit more secure. Also, do not forward private reverse lookups. So if you're just trying to reverse resolve a host on your network, you may want to check that option so that those queries for reversing local networks don't bleed out to forwarding the servers, which could, in some ways, reveal a little bit of information about you if somebody happens to have, taken control of your upstream DNS server. All right, so let's talk a little bit about host overrides and what those are. These work the same in the DNS Resolver and the DNS Forwarder. You'll have the same fields in both of them. What these are is they are custom DNS records that are A for IPv4 or quad A for IPv6, and they'll give you an answer. They'll give the client an answer back for hosts that either don't exist in upstream DNS, or it will override a response and return something else that you want. The most common use for this is going to be things like split DNS or development servers, things that, or private servers that you have that exist locally, but you don't want to put your DNS records for in public DNS. So you're going to want to override those responses in those cases. You could also use it for some lightweight blocking, returning a bogus result for like Facebook or something like that. It's not a great way to block that because there are ways around that, but it can be used to that effect if you want to try it. So basically, in a host override, you're putting in a record that will get returned back to the clients, and that client response that it gets, it's going to be exactly what you want. And not what's in DNS upstream. So whether you want to do something that doesn't exist or you want to do something that you just want to change the answer for, it's fine. Split DNS is the best example of that. I started to mention it a moment ago. Say you have a web server on your network with a local address. Public DNS is going to get a public IP address on your WAN. It's going to hit that, but you don't want your local clients to hit that public IP address because it's wasteful to bounce that off the firewall and rely on NAT reflection, which is a bit of a kludge too. So what you do is you put in an override so that your local server resolves to the local address, and then that way your local clients will talk straight to the local address of your server, and it could may not even have to hit the firewall depending on where the two are located, or it would at the very least it wouldn't have to rely on NAT or any other trickery to make its way back over to the server. It would just go directly, which is a lot more efficient and a lot less to go wrong. All right, moving on to domain overrides. Similar concept to host overrides, but for an entire domain. It lets you define an upstream server where you're going to send all these queries for an entire domain. So you have your domain that you're going to put in there, like site2.mycompany.com or whatever. IP address is the IP address of the DNS server that's going to be able to give you a response for that, whether it's an authoritative DNS server on the other side, or it's a recursive resolver that's going to get you that answer. You can put that in here, and for the resolver, you can append an @ after there to use a custom port number if you want to. That's a rare case, but you can if you need to. And then there's a description if you want. So these are useful for your local domains like Active Directory, things like that across a VPN. It doesn't have to be a real domain. It can be one you've made up or just one that you use internally. You're basically just saying, okay, if I have a record under this domain, it needs to run through this other server. It doesn't, it's not something that's going to be public, or, you wouldn't have to bother with a domain override. It could be something like a fancier server that can provide you a different view of DNS, whether you're coming across a VPN or you're coming across public, and you would want to come across the VPN to get your internal responses and things like that. The DNS Resolver, if you know a little bit about Unbound or if you used it before, the DNS Resolver uses what's called a forwarding zone now on 2.3 and not a stub zone. We used a stub zone at first on 2.2, but those had some limitations that were not very good, because a stub zone has to talk directly to an authoritative server, whereas a forwarding zone can just talk to another forwarder, and it doesn't really care whether or not the next hop is authoritative. So if you're talking to another server that has to in turn pass that query on to another server, stub zone's not going to work for you. So forwarding zones are better for that. If you have to use a stub zone, there's a way you can do that in the advanced options. There's some notes around Redmine, I think, on the wiki on how to do that if you have to, but almost nobody should have to do that. Now, this is a little bit different for the DNS forwarder. It has a couple more options that the resolver doesn't. And this is where it can really be a little bit more better to use the forwarder for for IPsec and things like that. It has your domain and IP address as usual, but it also has a way to set a source address so that the query will be sent out from a specific local address. So say you'd put your LAN IP address in there or something inside an IPsec phase 2. And I'll talk a little bit more in detail about when I get to VPNs here in a couple of slides. You can also have a couple more ways to control the responses here. If instead of an IP address you put a # in there, like for a subdomain, it will forward that up to your standard name servers instead of an override. So you could have example.com override going to a local DNS server, but then like pub.example.com could pass through and go up to public DNS servers. You could have, and you can also have, and that's what the #, there's an exclamation point there too, that tells it not to forward a request anywhere. So if there's a domain you've got locally and you want to make sure that nothing bleeds out anywhere for that to public name servers at all, define that domain, put an exclamation point here, and that will stop it from trying to do any forwarding for queries in that domain, which is good for extra security. All right, well, segueing over here into VPNs, for VPNs and firewall DNS, when you have a VPN or a private link connecting these multiple sites, you can use domain overrides like I was mentioning. You can make it so they can talk back and forth with each other, but they have to be using different domains or subdomains at each site. So you'd have like site a.example.com. So, say you've got a host there that's, Bob. So you have like bob.site1.example.com. And then over on your other side, you could have another person named Bob. They would be bob.site2.example.com. And they don't conflict, and they're different. They're different domains. They behave independently, and you can query them all, just fine over those, because you can have a domain override just for that subdomain. Or you could even have it be like site1.local or site2.local and just do it with plain domains. That's all, up to you and however you want to run that. But, it's got to be different, because if you try and do the same, like I mentioned earlier, you're going to run into all sorts of headaches. Now, if your VPN is using OpenVPN, or even if it's using like a dedicated link like MPLS or something like that, you're not going to have any issues. The firewall is going to send those queries out from your tunnel network or a direct interface. So you may need to account for that in your DNS ACLs or firewall rules on the far side. So it's not going to come from your LAN. But if you're using IPsec, it's a little bit more complicated. If you're using the DNS forwarder for IPsec, you need to set that source address, like I mentioned, to be a local address that's inside that phase 2. So usually it's going to be your LAN IP, and you're going to set that source there, and so that when it goes to send that DNS override query across your IPsec VPN, the source is going to match your phase 2, and so it will actually carry across the tunnel where it otherwise wouldn't. If you're using the resolver, the easiest way around that is to set your outgoing query interface to be just your LAN or whichever local interface is inside that phase 2. The downside to that is it's going to make all your outbound queries get NAT, but it's not fatal, it's just not ideal. There's another gateway and static route trick that you can do to nudge the traffic over IPsec. Basically, you define a gateway for your LAN IP address, and then you add a static route for the far side network, and using that gateway, and then it'll do that. There's some quirks with that though. If you're interested in that, you can hit the wiki. It's on the wiki with a good explanation of why you would or wouldn't want to do it. Now, alternately, if you're not just doing an override, if you're actually wanting to send all of your DNS queries through the other side, then you would have to not just do a domain override, you would have to set up forwarders for that. So in the DNS Resolver, you'd have to enable forwarding mode and then set your DNS server, the only one, as the DNS server under System and General Setup. Make sure you have the option to get your DNS from DHCP or PPPoE disabled. DNS Forwarder, you just need to do the latter part of that. You just set your DNS server, the single one, under System General Setup, and then disable the DHCP and PPPoE. When you have it set that way, it's only going to forward queries to that one defined server, and then you can get all your answers across the VPN that way. All right, going back to multi-WAN now, a little bit about those. Both the resolver and forwarder can be compatible with multi-WAN, but you have to have some adjustments in both cases. By default, the DNS resolver, being a resolver, it will query random root servers and other authoritative servers that you can't really control. So you can't say, like some servers go out WAN, some go out WAN 2, like you can with the forwarder. So if you want to use the resolver with multi-WAN, the easiest thing to do is just enable default gateway switching under System Advanced on the Miscellaneous tab. And then when your WAN goes down, it'll switch that default gateway to WAN 2, and Resolver will just send out its queries like normal and get the expected responses. For the DNS forwarder, all you have to do is visit System and General Setup and put at least one unique DNS server per WAN. So you'd have like 8888 going out WAN 1 and 8844 going out WAN 2, and maybe an ISP DNS server for WAN 1 and then a different ISP DNS server for WAN 2. So you have that gateway choice, and here, let me show you. General Setup. So I don't have that. I don't have all my DNS servers set that way, but I could do 8888. Forced out of the WAN gateway, 8844, going out my WAN 2 gateway, like that. And then that way, it's going to add a route to make sure that that DNS server goes, the way you expect. And so this way, if one WAN goes down, I still have DNS out the other WAN. And because of that parallel query feature of the forwarder I mentioned earlier, it's always going to get a good, fast response. Now the resolver, if you want to use it in that same concept, you just need to enable forwarding mode and then set your DNS servers up the same. The only other thing you might have to mention, you might have to tweak there, is you may have to disable DNSSEC if your upstream forwarding servers don't support DNSSEC. But otherwise, enable forwarding mode, set your DNS servers exactly like I did here, like 888 out WAN, 8844 out WAN 2. And then it will do that. Now, because of what I mentioned earlier, Unbound tracks, the resolver Unbound tracks the DNS server quality a little bit differently. So there might be at least one timeout you might get. So it might take the DNS a little bit longer to pick up on that change with the resolver than the forwarder. But ultimately, it's not going to be that big of a difference. Now, another tactic with multi-WAN that's perfectly valid is to not use the firewall for DNS at all. If you set your clients to use the public DNS servers like Google Public DNS, if you set them to use those addresses directly on the clients and not use the forwarder, then that DNS request will just hit their policy routing rule and go out whichever WAN is up, according to wherever they're policy routed. So that is just an alternate tactic you might take to do multi-WAN DNS if you really want to avoid any of the configuration that you'd have to use for the forwarder resolver. All right. A little bit about DHCP and DNS. Both the resolver and the forwarder can support registration of DHCP host names for dynamic and static leases. So like over here in our settings, you'll see there's a DHCP registration box and a static DHCP registration box. If those are checked, there's a DHCP leases daemon that will run, and it will monitor the leases file, and it will take the host names it finds in the leases file and put them into like your host file, or or the host file that's used by Unbound, and the host configuration file, or for DNS masks they're just in/etc/hosts. The static DHCP entries are taken from your static mappings in DHCP. The DHCP registration ones are taken from the leases file. And in order for that to work, your DHCP clients they have to supply their own host name for dynamic leases. For static leases, it will take whatever host name is listed on the static mapping. So if your clients are configured with an invalid or empty host name, or configured not to send a host name at all, they're not going to be able to resolve those, obviously. And and when you're doing that, you need to be extra sure that like your firewall is using a subdomain, like site1, like your firewall, say firewall.site1.example.com. Because you don't want a client to give you a name that is going to directly conflict with something just on your root domain. So in my little example here, if you had a client computer, just a host PC that named itself www, if it registered itself in DNS and you were just using a plain domain on your firewall, it would then essentially be trying to take over www.example.com, which could be a big problem for you. Whereas if you had your firewall on a subdomain, it would be like www.site1.example.com, which is a lot less likely to be a problem. Now, in reality, that you could, if you have a client like that, you go and kick them off your network, whatever. But or you wouldn't do DHCP resolution if you have malicious clients like that. So it's something to consider. Another nudge toward using a subdomain at every site. Another note here: if you are using a high availability setup, like a cluster using CARP and everything else, the host names are not exchanged between the high availability nodes. Each node runs DHCP independently on a different segment of your pool, and they share lease information between the two of them. So they're always running, both of them. They're always handing out these leases, but they don't share the host names like they should. But that's a bug in the ISC DHCP daemon, and they're going to have to fix that upstream. But it's something to be aware of if you're doing that. We have seen some people try to pull off some trickery with the forwarder and resolver, trying to get the two nodes to exchange host information, which it's kind of ugly. But I mean, if it works, it works. But it's kind of ugly. So really, we don't recommend doing that. If you are in that in that kind of situation, you really need that. You might need to set up a dedicated DNS server where these clients can register their host names directly. And building off that with DHCP, by default, the DHCP servers and the DNS servers in the DHCP settings are blank. And so, that's the best thing by default, because the firewall will hand out itself, given these criteria. So if you were to have DNS servers filled in the DHCP settings, they will always be used. So those are what's going to get passed to clients. If those are blank, then the firewall looks and says, if I have the DNS Resolver Forwarder enabled, it'll hand out its own address. If it doesn't have the Resolver or Forwarder enabled, then it will look at the DNS servers you have defined under System General Setup, and it'll give those to clients. And then if you have none of those, then it won't give the clients DNS servers at all. Sorry, there, had a cough. And so that, that little structure of logic is how it figures out what to give to clients there. So it's something to follow along. The most common case, you're going to have the resolver or forwarder enabled, so it's going to give the firewall out itself. Otherwise, you probably want to define something manually in the DHCP settings. All right, so here's a little trickery you can do to prevent clients from reaching external DNS servers that you don't want. Sort of the same idea as using Squid for a transparent proxy. It's going to intercept their DNS requests and have the firewall answer them directly. Now, because it's kind of tricky, it might not be a great idea for a public access network because people aren't going to expect it, or you might want to let them know you're doing it. I don't know. It's really up to you and how you want to run your network ethically, but in some cases, especially a company, it can be a good security measure. Or it also provides a little bit better user experience because you don't have to deal with calls from people who have manually set DNS servers on their computers and they don't know what they're doing, or they don't realize they're there. It's all just going to work without having to think about it. An alternate tactic to this would be to block access to all DNS except for the firewall itself, and then people would if they don't have DNS, if they try to set some other DNS server, they could be taken out that way. Well, you can't get connectivity. Well, it's because your DNS servers are down. But if you do, after all that, you still want to capture these DNS requests. It's really easy. All you do is you set a port forward on LAN for TCP UDP for a destination that is not the firewall's LAN address. Destination port range 53. Redirect target is localhost 127.0.0.1. Redirect target port 53. And I have that rule over here, and I'll show it to you. So here it's TCP UDP, not destination, not LAN 53, forward to localhost port 53. And I've got a description of capture DNS. If you want to look at that a little closer, same thing here, interface LAN, protocol TCP UDP, invert match, LAN, DNS, localhost, DNS. And how that works is if a client tries to reach any other DNS server except the LAN, it will intercept that, send it to localhost into the DNS Resolver or Forwarder, and then it will answer back out of there. So I'm looking up just google.com here on this host. You see I get an answer. But if I do like yahoo.com from just a bogus server address 1234, I still get a response. If I look up, let's see, CNN.com on 78910, I still get a response. So no matter what, they're always going to get a DNS response from the firewall, no matter what DNS server they try to use. So again, if it's something you think you might want to do, it's really easy to do, but it's something you might want to make sure that people know you're doing it, because there might be some people who have a reason for using an alternate DNS server, and if it doesn't work right, then it could cause some trouble for specific applications. All right. Tyler said, intercepting DNS requests and replying from another source than the expected source may result in an ICMP port unreachable. That won't happen in this case because the NAT will make sure that on the way back, it looks like it came from the server they queried. So it won't send that response back from a different address. It will actually look like it came back from the server they tried to reach. So you won't have that problem. Okay. It's just a few miscellaneous things. I got a couple slides of things that didn't quite fit into any other category here. Both the DNS Resolver and the DNS Forwarder, they provide DNS rebinding protection. What that helps protect you against is an upstream DNS server that provides a response with a private address, which can be okay if you know it's happening, but it can be used to attack your firewall. So say somebody tricks you into clicking a URL. You could be clicking a URL that you think you're going to, blah.example.com, and that is actually resolving to your firewall. And if you are logged into your firewall, you might be visiting a URL on your firewall that you don't intend to visit, or might be posting data to something there you don't intend to do. It could be used to have an attack like that, because you're going to a host name that somebody else controls, but it resolves back to your firewall. So that is not a good thing. But there are cases where you might want to have private responses for certain domains. Like say you've got some of your internal DNS records in public DNS, which I wouldn't recommend you do, but it can be done. So in that case, in either one, you could go and disable the DNS rebinding protection entirely under System and System Advanced, just on the first tab there, but that's not very secure. So in either the resolver or the forwarder, you can use the advanced options to set up a bypass for DNS rebinding. Now in the DNS resolver, you just put server : to make sure that it's in the right context, and then private -domain : and then your domain name in quotes. And that will allow private responses in that domain. Similar with DNS forwarder, you got rebind -domain -ok // and then your domain and then /. And if that's in there, then that's going to allow DNS rebinding type queries on that domain only, which is good. I mentioned a little bit earlier already that both the resolver and forwarder support selective interface binding, so you can restrict where your queries are answered. The resolver can set the outgoing query interface so you know where it's going to source those queries from, so I already covered that. You can do both the resolver and the forwarder at the same time on different port numbers. Again, not something we recommend, but you can do it. Whichever one you have running on an alternate port, you could use that. You could direct clients into that with a port forward, because the clients are going to want to hit port 53. So if there's a certain client you want to hit the forwarder instead of the resolver, you can run, for example, the forwarder on port 5353, and then have a port forward on LAN that redirects that client to port localhost on port 5353. Then they will hit the forwarder instead of the resolver, for example. So it can be done. We don't recommend doing it, but there you go. We have in the GUI our diagnostics DNS lookup, which lets you just run a quick DNS query and get back a response, and it'll let you do like ping and trace out and some whois and some other information about it. It also it gives you back timings. It shows you how fast your DNS servers responded. And it gives you all the records there. You can also take this response and create an alias from it. I wouldn't recommend doing that with a site like Google that constantly rotates these out. But if it's a site that has one static address, that's a simple thing you can do. Or you can even put the host name directly in an alias if that's the case. But it's just a convenience feature. If there's hosts here you want to make an alias out of them, you can. So this page is useful for checking to see if DNS on the firewall is working, and for some light diagnostic purposes, checking what host names resolve to manually, things like that, without having to have a client program installed to take care of it for you. The logs for the DNS forwarder and the resolver, they're under status and system logs. Under system, and then on the DNS resolver tab. And both DNS mask and unbound will log here. Show you on this one. And so they're all your logs are going to show up there. Both the resolver and the forwarder can both be set to log the queries that you receive. There are some cases where that's handy to see what's being queried. It's not something you'd want to run constantly because it's a lot of logging. It's a lot to sift through, and you might miss some other important things, but just showing you the queries. So you have the DNS resolver there. If you want to do that, you could just do log-queries : yes. For the DNS forwarder, it's just log-queries, and those both go in the custom options box. So you've got, so that's if you want to log queries, you can. And if you do have that enabled, everything that's queried is going to show up in that log. So you could use that to find out who is looking up a specific website. You could use that to find out, you know, where are weird queries coming from, or, you know, just usually it's when you're doing that, you're trying to find a specific client that's doing that, or you could just be trying to see, you know, everything that a specific client is trying to get to. So if you have a pretty quiet environment, say you're in a lab or something, you've got a device you're trying to see what all it's trying to go to, whether it's an infected host or, you know, a program you're evaluating, whatever, you can use that to sort of see everything that it's trying to do, which is a little bit easier than running a packet capture on its DNS and trying to extract the information out of that. But it can be useful in the right circumstances. Moving on from that, both of them can also be configured to handle wildcard addresses using the custom options box. Wildcard address will answer back anything on the domain, so with a specific IP address. So if you have a host name you're looking up, like say you've got www.example.com, it resolves back to a certain address, but you have a bunch of different domains on that same server, and you want everything to be everything you don't have defined otherwise to go to that server. So say you want to just make up virtual hosts or whatever inside of your own domain, have them all go there. That's what wildcard DNS lets you do. It will basically you could ask it for anything under a domain, even something that has never existed, and you'll get back that answer of the address you put in. It's a little bit much to read off, but you can see the queries there. You can find them in the slides after, or we've got them on the wiki as well. So in the DNS Resolver, you just basically set up a little local zone like that with a redirect. And the DNS Forwarder, you just put an address record in like that without a host entry, or you know in that specific syntax, you'll in either case you'll get a wildcard result out of it, which can be handy, but I can tell you firsthand it can also be annoying because you won't get back a non-existent response. It'll always get back something. Okay, so that's about all I had to go through. So I don't know if anybody has any questions or anything. Oh, I see, Brandon, you mentioned something about the audio. I don't see it cutting out or anything. If not, you know, the local copy I've got here of the video, I'll be uploading afterward, and it'll have clean audio. If anybody had trouble, if the audio or video is stuttering for anybody, it'll be up later. All right, so if you have any questions, go ahead and type them out. I know typing can kind of take a while, so you might, you know, just post a quick message, say, let me know you got one coming. Let's see, tips to prevent DNS leakage when using a VPN provider. I thought I had something in here about that, maybe I didn't. Basically, what you want to do there is to make sure that you only have them listed as an upstream. So sort of like I mentioned with forcing all of your traffic across the VPN, you know, make sure that that is the only server you have defined for DNS, and make sure you're in forwarding mode. If you're using the resolver, you have to be in forwarding mode for that. And then in that case, it would only forward to that, and then if that was down, you know, there's no fallback. It wouldn't be able to send those queries out anywhere. But if you're just using the resolver in its regular resolving mode, it's never going to use that server across the VPN. Or, you know, if your default route changes over to the VPN, it would send out over that. But still, forwarding mode is your best bet for that, and then just listing only the DNS server across the firewall. You can have some client issues with leaking across the VPN as well. And that's usually a problem on the client. We did just put an option into the OpenVPN client export package to prevent that leakage on Windows 10, because Windows 10 clients by default with OpenVPN, they were still sending your DNS requests outside to every DNS server, sort of like what the forwarder does. And there's an option we had to push to the clients. It's in the export package now, and it will be in whatever next version we have coming out. We'll have an option in the server to push it, but it basically adds a workaround to the Windows client that blocks access to all DNS servers except the firewall. Now that's not a concern for local clients when the firewall is handling the VPN going to a VPN provider, but it is a concern if you have remote clients coming into you. Okay. Simon, any control over how long DNS results are cached by the forwarder? Does it cache negative results? Off the top of my head, I don't think, at least nothing in our GUI for the cache result time for the forwarder. You can check the DNS mask man page. If you see something you want to do there, you can drop that in the advanced options. I don't think it caches negative results. I've never had a big problem with that coming from there. Certainly not. Usually in that case, it's the client caching the negative result, and Windows has been bad about that in the past. All right, Simon or Matthew says, if I'm on a domain with DNS, do I disable general DNS forwarder on pfSense? That's really up to you, because you can still let the forwarder on pfSense handle, or the resolver on pfSense handle the DNS traffic for the firewall itself. Your clients can be going to your Active Directory server, and then the firewall can be handling its own. It's more efficient to have the firewall use, like, say, the resolver on its own for its own DNS than it would be to have it always go out and reach your upstreams, because, again, especially in cases like Multi-WAN or when you have sort of flaky upstream DNS, it's going to be a lot more robust if you have them coming through the resolver or the forwarder with the DNS server set up right. So you don't have to disable that on the firewall. You can, but you don't have to. Let's say, Tyler, what if a device is hard-coded, disregard DHCP, and always use 8888? That capturing rule that I showed you in NAT a little bit ago, that's what you do for them. Just port forward on LAN, redirect the DNS request into the localhost, and then you have to capture the DNS that way. Let me show you that again. It was this rule here that I showed. That's the rule you'd have to use to capture like Chromecast type things that are hard coded, like 8888, 8844. If you want to force them to use your resolver or forwarder, you'll have to capture the DNS request that way. You could, in that case, if you wanted to only capture 8888 and 8844, you could like set up an alias with those and use that as your destination on this NAT, and not invert it. Just say, you know, if they're going to these DNS servers, redirect to localhost instead. But yeah, that can be handy. We've had to use this rule before for some people that had a Chromecast, and for whatever reason they couldn't get out to Google Public DNS, or they had issues with it. Make sure I didn't miss any of these questions here. Anybody else have any questions? So DNS Resolver could mess with the domain only in the cases when your clients are using the DNS Resolver, not the Active Directory server. It can't mess with it just by being enabled. It can only mess with it if your clients are trying to use it. Now, if you set your Active Directory servers in DNS or in DHCP, sorry, to use your own AD structure for DNS, then their clients are not going to hit the resolver. It's not going to hurt them to have that enabled, or the forwarder. It's not going to mess with them that way. You just wouldn't want to have your clients hitting it directly. I was just trying to quickly look up and see if I could figure out if there was a way to control that caching period. It looks like for DNS mask, or the DNS forwarder rather, there is an option you can set to set min-cache-TTL, because normally it'll take the time to live of the DNS record, and it'll take that as the caching time. But you can looks like you can use maybe min-cache-TTL to control that, or yeah, there's also, you can do neg-TTL to control negative response time to live. And there's also a max cache TTL. So yeah, if you look up the DNS mask man page, there are a bunch of TTL control options you can use to dial in on some of that. So yeah, see, there's a bunch of TTL options you can use to tweak in there, and you can just drop those in the advanced options. Okay, anything special with regards to IPv6 DNS, or just the same principles? No, it's all the same. You can set IPv6 DNS servers under System General. You can receive them automatically upstream, just like before. If you have IPv6 enabled, the resolver will try to use it. So really, there's not any much of an extra concern. It's just in forwarding mode. If you want IPv6, if you want to send queries out over IPv6, you will want to set a forwarder server that's IPv6, and it's smart enough to pick that up and use it. Let's see, somebody is asking about DNSBL and pfBlocker NG. I did not cover that today. There was a separate hangout on pfBlocker that covered all that a couple of months back. You can find that in the archive. All right. Anything else? Anybody else? Yeah, does it need more DNS in general than 4? Yeah, 4 is getting to be a bit limiting. I don't think there's any technical reason we can't have any more than that right now. It's just that the code was coded to handle 4, and it's something we could certainly look to expand. I think there's a ticket, actually, a feature request out there to expand that. I can't remember what it is off the top of my head, but it's hanging out there. It's just something we haven't had a giant motivation to fix, but it's out there. It shouldn't be too hard, at least in theory, to have more than 4 out there. But especially in cases when you have more than 4 WANs, you really want more than four spots there. But that's something we're working on. Let's see, Simon, rough ETA on 2321? I don't know. We don't really have any ETA for that. All of our developers at the moment are focused on trying to get 2.4 into a usable state. And then we might turn some attention back toward that in a bit. But there hasn't been any compelling reason for us to move on it yet either. We haven't had any major security issues or anything like that come up. So it hasn't been a big priority concern. Well, that's it. I think I'll go ahead and call it there. We'll have this video up in the archive. I don't know if it'll be later today or over the weekend at some point, or at latest it should be up on Monday. We'll have the slides and everything else up there too. So if you have any comments or questions or future Hangout topics you want to see, drop us a post on the forum, comment on the blog, find us on the pfSense subreddit, whatever. We're hanging out everywhere. So just let us know, and it's been a pleasure, and we'll see you back next month.